All right. That's the danger nowadays, man. I don't remember anybody's phone number. If I ever go to jail, I have no idea why I would. I'm screwed. If I don't have my phone, I'm screwed. I don't know anybody's phone. Okay. So what we got into yesterday, I sort of took a little bit of a step back to match up with the book. I wanted to lay the foundations of trig down. We have our 6 trig functions, and 3 of them are kind of silly, because they're just the other ones flipped over. Yes? And I desperately want you to always remember what we did yesterday. We just wrote ratios of numbers from a triangle down. And that led to the trig functions. That's where they come from. That's all they ever are. So I kind of took a step back, and I went back to just look at angles by themselves. So we use degrees, primarily. Are we talking about the fact that degrees suck because they're completely arbitrary? There's no universal reason why it should be 360. I guess I need you to understand this. So in a sense, degrees are not good. And the little deeper I get into this, I can really show you exactly why they suck so bad. How many degrees in a circle again? Yeah, so it started at 0 degrees and it come back to 360. Good Lord, Jeff. I can almost write. Now, let me ask you this. Do you remember, I think the last thing I did, let me do this again because I did it a little quickly. And I'm going to do it quickly again. Sorry, 9 o'clock. Here's my little unamused circle, dude, right? It's like, if I pick that radius up, slap it down, and then curve it, and then fit it back onto the circle, how many radii did I just walk if I walk this far? I literally just walked 1 radius worth of length, yes? But do you also see how, I don't know if you ever heard this word, and I'm not going to use it a ton, but just to give it to you in case there's somewhere in the book that says it, we call that subtending an angle. So if you ever go in a curved path, you have subtended an angle. You've gone through an angle. You guys see if I walk a circle, I have gone through a certain angle. This angle specifically is 1 radius's worth of walking around the circle, so we call it 1 radian. So the word radian literally means number of radiuses, or radii, if you want to be technically correct. Let me stop for a minute. Several things. Do you see how that is physical? Not 360 made up bullshit, because we like the number 360, right? Now, real quick, there's nothing wrong with 360 degrees. You guys know degrees, they work, fine. But in terms of math and measurements and shit, it sucks. Radians are based on the specific circle you're looking at, its radius. It's a physical measurement, yes? It's not some made up bullshit. And I told you yesterday, what if the circle was much smaller? What if it was, look at that little tiny dude. Look at him. That little tiny. But what happened to his radius? It also got smaller by the same proportion. So if I take his radius, put it here, and I curve it, and I put it back on, hey, he's gone exactly the same angle. So 1 radian, it doesn't matter what circle it kind of lives in, it's always going to be the same angular movement. So real quick, let me see if you guys really understand this physical idea. What if I had a circle? There he is. Let's say the radius is 7. And let's say I walk 14. Let's give these units, feet, sure. What's the angle in radians?
2 radians.
Do you guys see? Let that make stupid amounts of sense. That isn't us going, I think 360 is good, and then we cut it. No, where'd 360 come from? Out of our asses. Actually, from the Babylonians. We stole it. We're good at that. How did you get 2, literally? Really, how did you get 2? What did you do? Yes, 14 divided by 7. You with me? Is everybody really with me? Okay, okay. So what if I had a circle whose radius was 1.17 and I go 0.93? What angle is this in radians? So
0.7.
How'd you get it? Sorry, how'd you get it?
0.93.
Yeah, how far I went divided by
1.
how big each radius is will tell me how many radii fit. And of course, did I go one radius worth? Did I go a full radius worth of distance? I didn't go 1.17, so I expect my answer is going to be less than 1 full radian. I went less than 1 full radius. And I'm sorry, I'm reading. Tell me again.
It was 0.79487.
Blah, 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 blah. Yeah, radius. Do you guys see how that's actually so much better? It makes physical sense. All right, let's go back to theory now. You know, we have to do that every now and again. Has everybody got that business? Ruh-roh. Yeah, I wrote small and I write bad. That's a bad combination. That says rad for radians. Okay, so what if I have just a generic circle? Yeah. With a radius of r. So now he looks content. What is the circumference of the whole thing? Do you guys remember from yesterday? 2 pi r. Yes? Now. So if I walk around this circle, how far have I gone? 2 pi r. And how do I figure out how many degrees, how many radians I just went? No. How big is the radius? What did we do? What did we do here? I took how far I went divided by the radius. I took how far I went divided by the radius. How far did I go? If I go all the way in the circle? 2 pi r. And I divide by r, because that's how big the radius is. I want to see how many of these fit in here. So what do I get? 2 pi. So all the way around a circle is 360 crappy little degrees, or it's 2 pi radians. So what's halfway around a circle in degrees? If I go halfway around a circle, how far did I go? How many degrees? 180 degrees. How many radians did I go if all the way around is 2 pi? All the way around is 2 pi, and I go halfway. 1 pi. So pi radians is 180 degrees. The same way 12 inches is 1 foot. And of course, the minute I know a statement like 12 inches equals 1 foot, can I convert between those? Can I convert between feet and inches? Yes. I just divide and multiply wherever necessary. You guys kind of with me? Has anyone ever taken, oh God, I don't want to freak you out. Has anyone ever taken chemistry?
Yes.
Okay, one big thing about chemistry, I'm sorry. I could feel the trauma. Sorry. I only know enough chemistry. They got me through my physics, and that's not very much, which is good. No, nothing against chemistry. Sorry. A lot of chemistry is conversions. Do you remember Avogadro's number and moles and grams and blah, blah, don't just stop, Joe. Okay. So watch this. When I convert, I kind of borrow a little bit from chemistry. But just the tiniest bit. No Avogadro's number, no piv nert. Okay. Let's say that I have, what do you got, Jeff? 60 degrees. And I want to convert that to radians. Here's how I borrow from chemistry a bit. I want to go from 60 degrees, I want to go to radians. So what do I want to get rid of? What do I not want anymore? I don't want degrees. Where do I put degrees so that they would cancel? In the bottom. So if I put something degrees down here, these cancel, yes? And on the top, I'll put radians. Now you just fill in the numbers in the right place. How many radians is how many degrees? What's the thing we just came up with that's sitting right there? How many radians is how many degrees? Pi radians is 180 degrees. I get 60 pi over 180. Can I reduce that? Pi over 3. So 60 degrees is pi over 3 radians. So you are going to eventually memorize certain radians measures. Pi over 3 is going to be important. What's pi over 6? How do you convert the other way? The other way is actually stupid easy. What if I had pi over 6 radians? Here's why this is easy. I don't even have to do the stupid little thing. What is pi radians in terms of degrees? 180. So if I have a pi in my radians, I just replace it with 180. Because that's what the dumb thing is. So this is equal to 180 degrees divided by 6. And what's 180 divided by 6?
30.
So pi over 6, since I'm taking pi and divided by more, it becomes smaller. Pi over 6 is 30 degrees. Pi over 3, I'm dividing by less, it should be bigger. Pi over 3 is 60 degrees. What's pi over 4? 45 degrees. 30, 60, 90, 45, these are all very important. What is 90 degrees? If pi is 180, what's 90 degrees?
2 pi over 3.
Half a pi. If this is 0, this is pi, this is half a pi, yes? Because I went halfway. Okay. So already this is much more kind of physical than the made-up degree bullshit. How we all feeling? So just to show you, sorry, I like it when somebody's very honest. Keep going. All right. What if I gave you 2.97 radians, and I want that in degrees? Do you see an explicit pi that I can use a shortcut and just replace it with 180? Does it say pi anywhere? Damn it. So, if I have a pi in my radians, I could just put a 180 in. Yes? Because that's what pi is. I don't have a pi of shit. So I have radians. I want to go to degrees. So where do I put the radians so it cancels? On the bottom. And then I just put the right numbers in the right place. How many degrees is how many radians? 180 degrees is pi radians. And then you just throw all that in the old calculator. 2.97 times 180 divided by pi. You throw all that in the calculator, you get some freaky decimal. Yes? It'll be roughly, holy shit, yeah, it'll be like 177. Probably less.
Multi-calculator for pi?
Sorry?
Is there like a?
Yes, there's this over here somewhere.
I found it.
Yeah.
Wait, where is
Oh,
it? I found it.
you found it, okay. Yeah, do not use 3.14. You have an explicit pi button right there. So if we do 2.97 times pi, times 180, divided by pi, 170, okay. So 2.97 radians is roughly 170 degrees. Let that by itself be nice. If you just remember, just like you know 12 inches is a foot, just remember pi radians is 180 degrees. You can convert between them.
Is that always true?
So again,
Is that
the
always
pi
true?
radians is 180.
Yeah, or is that just ours?
Let me say a very teacher thing. In the geometry, we're studying this. So yes. Okay. So I want to do, let's see. All right, one last little thing that I can squeeze in here. Do you guys remember when we looked at an equilateral triangle and we cut it? Yes, did we do that? And we figured out a couple things. we figured out that sine of 60 degrees is rad 3 over 2. Do you guys remember that? We actually proved it. Because our equilateral triangle was not just one triangle, it was every equilateral triangle that has existed and ever will exist. So we proved it, period. We also proved cosine of 60 degrees is 1/2. Yes? And then I believe we went further and we figured out that sine of 30 degrees is 1/2 and cosine of 30 degrees is rad 3 over 2. So, okay, and these are all things you're going to memorize. I am going to give you ways to make it less memorization and more just do what makes sense, because I hate memorizing shit. I do. That's why I suck at biology, because most of it is memorization. If you love biology, good. That's great. We need them. Ain't gonna be me. So now what I want to do for today, in a little bit of time, I want to look at a 45, 45, 90. If both of those mouths are open to 45 degrees, what must be true about the sides across from them? They have to be the same length. In fact, does anyone know what kind of triangle this is? Yes, isosceles. You guys with me? Isosceles. So, do we know how long this is? No. So what do I call it? But then we know how long this is. This has to be x. Good. And then this, let's figure out how long this is. Can we do that?
Yeah.
Who helps us? Alright, old Greek dude. Someday someone will say that. You don't have to. So I get old Greek dude to help me. That last side has to be called what? Has to be recognized to be the what? Hypotenuse, so it should get really what letter to be correct? Well, sure, or C. But as long as you realize whatever I'll call it H for now. Whatever this is, it's got to be the guy that's by himself, yes? So it squared is the other two combined because it's the biggest one. Makes sense. What is x squared plus x squared?
2x squared.
Thank God, yes. Okay. Not x to the 4. Right. Powers can only change when you multiply because that's what they're based on. And how do I solve for x? I'm sorry, solve for h. Careful now. Square root. I don't put plus or minus because this is a physical triangle for now, yes? For now, he says. What's the square root of 2? I don't know. What's the square root of x squared?
X.
Yeah. So h is x squared root of 2. Now, which 45, 45, 90 triangles did we just show that for? All of them. They're all isosceles. Now, can somebody tell me what the sine of 45 degrees is from this? What's the sine of 45 degrees? Which ratio does sine tell you to make? Yeah, it tells you to make the y divided by hypotenuse, yes? So it'll be x over x squared to 2, which is, what do the x's do? So I get, careful, where is square root of 2? In the denominator. And then what do I have to do? That we talked about yesterday. You're going to get really used to this. You have to rationalize it. Yes? Square root of 2 over 2. So sine of 45 degrees is rad 2 over 2. Does anyone see why I shouldn't have to do any work for cosine of 45 degrees? Didn't we already do the work? It's the same stupid thing. And that makes sense. If cosine likes x, yes? Cosine likes x, so it loves it here. Cosine of 0 is 1. Sine likes y, sine of 90 degrees or pi over 2 is 1. They should be the same value in the middle, 45 degrees. Sine gets smaller, cosine gets smaller, and they agree right in the middle. That's why they're equal to each other. More technically, the dumb sides are the same length. So cosine of 45 degrees is also rad 202. So does anyone know what, yeah, there's sine, what the tangent of 45 degrees would be? It has to be 1, because what's tangent? Even better, it's sine over cosine. Since sine and cosine are the same, tangent's got to be 1. And then you could do the other 3 just by reciprocating, but I'm over my time. I appreciate you tolerating me doing that. I'll have the quiz graded tomorrow, and I'll see you then. Oh, don't forget your phone, whoever, please. Yo.